Lesson 10.18 is now putting all the pieces together into, we're going to determine the features of a rational graph. So we're not actually graphing, but we're going to go through and figure out how to find all of these things in the same problem. And so the first thing I like to do is find the horizontal asymptote. Remember, the horizontal asymptote is just comparing the highest degree powers. So for our note's sake, I'll just show the little work you need to know. And so I see both terms are x squareds. And so when they're the same degree on top and bottom, you're simply going to have y equals, and you divide the leading coefficient. So that'd be a -1 divided by 2. So y equals -1/2 would be the horizontal line. That's the asymptote. Vertical asymptote is where we need to start factoring. And that'll also tell us this other information. So I'm going to go ahead and take out a negative of the top, and that would leave me with x squared minus 3x minus 4. On the bottom, I'm going to divide out a 2. That would leave me with x squared plus 2x plus 1. Then I'm going to factor this trinomial. That would be a -4 and a +1. And that would be an x plus 1 times an x plus 1. Okay, so then I'm going to check for any holes. That comes from where factors cancel top to bottom. So at something, wherever x plus 1 would equal 0, that's going to be the x value of the hole. So think of what number plus 1 makes 0. That would be when x is -1. Now we need to plug -1 into our simplified function. So I'm going to go ahead and rewrite what's left over. That would be a negative times x minus 4 over 2 times x plus 1. Okay, and I'm going to plug in x is -1 here and here. So that would be -1 minus 4 is -5. -1 plus 1 is 0 times 2 is 0. So this actually is an issue because when I try to plug in that x value, I get something that's undefined that I can't get an answer to. So actually there's no hole. You'll just click that button on Delta Math. Okay, the next thing I'm looking for is, where is the vertical asymptote? Vertical asymptote comes from the denominator after you factor. And so I'm going to take this and set it equal to 0. Well, the 2 is going to do nothing for me. It's really just, where is x plus 1 equal to 0? That would be at x equals -1. And that's why there actually wasn't a hole, because we tried to plug in -1 and it didn't work. There's an asymptote there saying that graph will never touch there. So that kind of makes sense. And then the x-intercept is taking the simplified function and just go ahead and set. So think we're trying to find x, y is equal to 0. Think about if this were 0 and I cross multiply it here, that's going to get 0. So really I'm just taking the numerator, minus. Numerator set equal to 0. And so dividing by a negative is still 0. So x would be 4. So 4 comma 0 would be my x-intercept. Y-intercept, you could do it from the beginning, might be faster. You could do it here. You're simply plugging in x is 0. So see, this was where y was 0. This is where x is 0 into here. So it's going to be 0 minus 4 is -4 times a negative is 4. And then 0 plus 1 is 1 times 2 is 2. So 4 divided by 2 is 2. 0 comma 2. You could have also got it from here, like I said. So this would be 0, 0. You're left with 4. This would be 0, this would be 0. Divided by 2 is 2. So y-intercept and horizontal asymptote you can actually get without factoring. But everything else you have to factor to figure it out, because there might be a hole that's causing an issue. Okay, there's 2 more we're going to do. If you go to the next page. Our function is x squared minus 6x plus 9 over -3x plus 9. So I'm going to do horizontal asymptote, and I might go ahead and do the y-intercept as well. So I'm looking at powers here and here. See how it's top heavy. So I don't know if you remember that rule or not. When it's top heavy, think of that as like an improper fraction. That means there is going to be no horizontal asymptote when it's top heavy. Okay, and then y-intercept, if this is 0 and this is 0, I get 9. This is 0 divided by 9. So that would be 1. All right, now I'm going to go on to factoring this. So on the top, that would be x times x. That would be -3 and -3. On the bottom, I'm going to divide out a -3 and have times x minus 3. Okay, I do have a common factor that'll cancel, so there should be a hole. The hole comes from setting that canceled factor equal to 0 and solving, so that's at 3 comma something. I get the y value by taking my simplified function, which is now just x minus 3 over -3, plugging in 3. So that would be 3 minus 3 divided by -3. Well, that's 0 divided by -3. So y is going to equal 0 is where the hole is at. Okay, and then I'm going to find the vertical asymptote. That is taking the denominator and setting it equal to 0. Well, I don't even have an x here to solve, so there's going to be no vertical asymptote either. And then x-intercept we need to find. We know that y is 0, so we're going to plug in y is 0, cross multiply, that makes 0. So really we're just setting x minus 3, the numerator, equal to 0 and solving. So x would be 3. Okay, but let's think about this. I have a hole at 3 comma 0. So is that actually an intercept there? No. So actually this did not work either. There's no x-intercept. So if you find one of these characteristics actually has a hole at that location, then it doesn't actually exist. All right, and number 3. If at any point in time you want to pause and try it by yourself, you can. Okay, horizontal asymptote. Again, I see that it's top heavy. So that means there's none. If it were the other way around, x over x, when it was bottom heavy, that would mean that it's automatically the x-axis, which is y equals 0. Okay, and then y-intercept, that would be 0, 0. That'd be 16 divided by 4. So it'd be 0 comma 4. All right, now let's factor. So that would be x plus 4 times x plus 4 over x plus 4. Easy enough. Cancel and cancel. And so I have a hole where I take that factor, set it equal to 0 and solve. So that would be at x equals -4 comma something. Your new function is simply x plus 4. That's all that's left. So I'm going to plug in -4. So -4 plus 4 would make y equals 0. Then I'm going to do my vertical asymptote. And that's setting the denominator equal to 0. But again, I have something that divided and it's really just over 1. So I can't set 1 equal to 0. So there's no vertical asymptote. And then the x-intercept, I'm already seeing there's a hole here when y is 0. So I know there's not going to be one. But what you're doing is you're solving the numerator set equal to 0. So that problem actually ended up being very similar to problem number 2. I don't know that I intended that, but yeah, that's it.